So how many of you have ever come from an amazing trip or concert with dozens of video clips on your phone, only to let them sit for months in your gallery? We've all been there. Yes, yes, yes. People agree with me. We've all been there. So that's what we call editing nightmare. My name is Kristina, and I'm leading Android media editing team. With me today is Shahd. She's also on our team, and she's the hero today who will be doing live demo and a little bit of live coding. So please give her a little bit of applause as well to support. Yes? Thank you. Yes, thank you so much. So we'll spend a lot of time thinking about how to solve the editing nightmare challenge. And in this workshop, we will share with you a solution that we came up with. And you can add this into your app or your hobby project after this, hopefully. So if you have been following the news this year, AI is all about AI as an artist, where AI is creating videos from thin air. But when we talk to real creators, that's not actually what they're looking for. They look for AI mechanic, someone who will do a boring chores for them, boring trims and load tasks. But the creators still want to be creators. To understand these chores, think about your last concert or vacation. Or in our case, actually, for this workshop, we made for you a trip through our Google office in London. So if you have not been at our Google office, you will have the chance to see our compiled video. So capturing the trip at the moment is spontaneous and fun. You shoot something quick and put your phone away. But when you get home, you are left with dozens of fragmented moments sitting in a gallery. Just the thought of organizing all of those clips creates a massive cognitive load. I'm always thinking about that trip I took whale watching. And what you do, you're taking a lot of videos, like 5-minute video, where you see a whale just for 5 seconds. Every time I look at those clips, I was like, I need to compile something nice out of this, but I don't want to deal with the trimming of those videos. So this leads us to the editing nightmare. Trying to scrub through your gallery and manually stitch together 15 clips into a cohesive vlog is the high-effort, low-joy task you can ask a user to do on a 6-inch screen. It's exactly this kind of friction that stops people from sharing their stories. Can you feel the pain? I guess you can. Any of you in the audience wish for a magic tool that can create a 1-minute travel vlog with one click of a button? So stay here to learn how to do it. Today, we are going to show you how you can implement a solution to eliminate this challenge, either in your app or your hobby project. We will demonstrate how to easily automate video trimming and concatenation using Gemini and Jetpack Media3, doing the heavy lifting for you. In this workshop, we'll be using several APIs that you might be already familiar with from your day-to-day life as Android developer. I guess most of you are Android developers. Are you? Are you? Yes, yes, Android developers. So these are the 3 building blocks we need for this workshop. A Jetpack Media3 API, handling clipping and concatenation of videos. Firebase AI logic is used to query Gemini APIs. And Firebase Google Storage manages uploading of our videos to the cloud. First, Jetpack Media3 is an open-source media library. It makes handling audio and video easy. Finally, cloud storage for Firebase provides scalable and robust solution and storage we need to handle user videos. It also features integrated security rules to keep your files safe. In the next couple of slides, Shahd will guide us through what we are building and high-level architecture of our sample app.
All right. So now that we know our building blocks, let's have a high-level overview of the app architecture. We will now walk through this user journey screen by screen. In step 1, the user selects their videos and uploads them to Google Storage. And we're going to say why. In step 2, the app sends the complete prompt, including the video URIs, to Gemini API via Firebase AI for analysis and to produce the list of trim timestamps. And in step 3, finally, we use Media3 Editing APIs to compile the suggested video and view it to the user using Composition Player. So the rest of the workshop now will focus on the technical implementation of each one of these steps. So let's have an overview of the details. In step 1, the Android app lets the user select videos and upload those videos to Google Storage using Firebase APIs. In step 2, the user describes their desired result, and we send this complete prompt to Gemini. Gemini API analyzes the videos and produces a list of trim timestamps formatted as JSON. And in step 3, we use Media3 Editing APIs to compile the suggested result. So now we're going to jump to step 1 with Kristina.
Yes. So a quick reminder. So step 1 is where the user selects videos and uploads it to the storage, to the cloud. And you can see on the screenshot how the first screen looks like. And of course, we're using Compose. We'll be relying on the Photo Picker API and Firebase Storage to make this happen securely and efficiently. Many of you might be familiar with Photo Picker API, and I hope you're using it every day. So we'll be going through this very quickly. In the Media Selector screen file, line 38, for you who is following the code, we use Remember Launcher for activity result with the Pick Multiple Visual Media contract. This gives us a beautiful native UI for selecting multiple files. Probably nothing new for you. To be able to select only videos from the gallery, we specify request video only so that user only is able to select videos that we can process. Some of you might be wondering, but why do we need Firebase Storage? Why do we need upload videos to the cloud? Can't we just attach the videos directly to the Gemini request? And that's a fair question. That was my question as well. And the reason it doesn't work that simple is that we have a 20 megabyte restriction for the Firebase AI logic request side. And you can only send one file, either video or images. Because of this strict limitation, we cannot realistically send several videos directly with Gemini API request. This is exactly why we need to upload the videos to Firebase Google Storage first, so we can simply pass the URIs in our Gemini API request. So we upload to Firebase Storage. This code block details the upload process. For each local file that user selected, we upload it to Google Storage, and then we store the pair together, a local URI and the remote URI. And why do we need this pairing? Is that the analysis will happen in the cloud, and Gemini will use the remote URI. But we want to keep the link to the local file, so we keep sending back and forth video files, and we just using the local files with the data generated by Gemini. As a side note, for production application, you might want to consider uploading to the cloud the limited file size. So for example, using Media3 Transformer APIs will let you downscale your files so you can save on the time to upload and also probably save some money for the storage. Under the hood, we push the file to the child reference named with the random UUID, await the task, and most importantly, construct the GES storage URL, which is required by Gemini. This is all the code you need to select and upload videos to the cloud. That completes the first step in the upload process. Everything is stored and ready for processing. Shahd, are you ready to show everyone how Gemini analyzes those videos?
Let's jump to step 2. So in this step, the app takes the Google Storage URIs for all of the uploaded videos from step 1 and the user's intent that they can enter in a text box on the first screen, and we send that complete multimodal request to Gemini API. We leverage Firebase AI logic and the Vertex AI backend. Gemini will then analyze the videos based on the user's prompt and produce a structured list of trim timestamps formatted as JSON. To get the best result out of our model, we rely on careful prompt engineering. In our system prompt, we explicitly tell Gemini to analyze the provided videos with an ask get to identify the single most engaging moment in each one of them. This ensures the AI focuses on identifying the absolute best moments from the videos. We also add granular details to this prompt to ensure the AI's response works perfectly with our code. As highlighted here, we explicitly tell the model that its final output must be a single JSON file containing entry for every video listed. By enforcing this strict instruction, we guarantee structured response that accounts for all of the videos we uploaded. So now that we know our prompt, let's jump and see that in the code. So we're going to start by looking at how we set up our Gemini model. So we'll be looking at the Gemini repository class. At the top of the class, we define our AI model using Firebase AI and setting our Vertex AI as the backend. We are targeting a Pro model in here. This is using 2.5 Pro, but of course, you can use other versions, newer versions. But we want a Pro model because video analysis is a complex multimodal task that can benefit from the Pro model's reasoning capabilities. Notice the different configuration parameters that we have here. We set a temperature of 0 to ensure the output is predictable and consistent. And we have response MIME type set to application/JSON. And we provide our JSON schema that we want the model to be strict and give us something that has the same structure. So I want us to quickly check this JSON schema. Looking at the schema here, we have an array of videos. Each video in this array should contain the following: the URI of the video, and the most engaging segment, which is represented by the start and end timestamps in millisecond, and the reasoning for AI to tell us why it shows these segments exactly. This is a small example of what things should look like. Hopefully, it's clear. We have, for example, for the first video, the Google Storage link. And we have the start and end timestamps telling us, OK, like the best segment here is from 1.5 seconds to 5 seconds. And this is the reason why. So now that we have our AI model set, let's go back to Gemini repository and see how we do our Gemini model call. So we are looking at the generate edit response method that takes in the prompt and takes in the URIs. We first start by constructing the request content. So for the request content, for each video, we take that and we put it in a file data block and passing in the MIME type, telling AI that this is a video/MP4 file, so we can help it identify that. And we put in our prompt in a text block. This has our request content ready. So we call AI model.generate content, passing in our request content in here, and just wait for a response. Once we have a response back, we extract the AI thoughts and the AI response text and pass them back to the Gemini in a Gemini response data class. So this is how we do our Gemini model. Let's see how we orchestrate all of this in the view model. So now we're in the media selection view model. And I want us to be looking at the onEdit with Gemini clicked method. So when the user clicks Edit with Gemini button, there are two steps that would happen. First, we upload the videos to Google Storage, as Kristina explained in step 1, keeping in the important mapping of uploaded URIs to local URIs for on-device editing later. And in step 2, we want to call Gemini to start doing the work. So we construct the prompt by fetching the sample prompt that we explained before in the slides that lives in generate simple preamble, and pass in any intent text that the user added on the first screen. We then call in Gemini repository.generate edit response, passing in this prompt and the URI pairs, and just wait for it to give us the result back. Once it has the result back, we populate that for the UI state, which should take us to the third step. So now we started, in step 2, we started with a list of uploaded URIs for the videos. And now we ended up with having a response that's a JSON file containing the start and end timestamps that we should select for each one of the videos. And of course, we need to parse that JSON file, but we didn't include that information here because hopefully people know how we can parse JSON files and use the different APIs that are available for that.
Now, we are already 60% done with our workshop. Now that we have analyzed the input videos, we are ready for the final step, assembling everything together with Media3 library. This is a personal highlight for both of us, as this is the APIs we are working on our day-to-day roles. In this workshop, we will be focusing specifically on editing APIs to create the output video based on the suggestions from Gemini. For this step, we'll build a composition object first, and then preview it with Composition Player. To understand the APIs we're about to use, let's break down the editing journey. It typically follows the editing loop, continuous loop. Build, preview, and edit until you're happy. And then when you're happy, you export the result. On the next slide, I will show you each component from Media3 that maps to these steps. We use composition object to handle our build phase, defining our clips and effects. We use composition player for previewing in this loop. And just as you're happy with your edits, we use transform APIs for export. This covers the entire life cycle. So before we jump into code, I really need to get deep into details on composition object. And composition object is the core structure for editing APIs, so it's important for us to understand it. To quickly introduce our data structure, every composition is defined by a collection of edited media items. Each editing media item contains a raw media item and effects you want to apply to it. Also here, you need to apply clipping configuration on media item to define your trimming configuration. So for example, when is the start and the end of the clip, and how you want to trim it. To introduce the dimension of time, we use edited media items and put it into edited media item sequences. So that this is organizational layer, and we're using it to determine how and when each clip will be shown. And the name sequence will tell you that they go sequentially after each other. To finalize the structure, we assign an arbitrary number of edited media item sequences to the top container, the composition object. This means a single composition can be scaled from a simple single edit from one item to an arbitrary number and complex project with multiple videos and images. And that's how all these pieces fit together. And I know it might look very abstract and complicated at the moment, but it's really straightforward when you see it in code. Now that we have this in mind, let's look how it looks in code. Shahd will demonstrate the code and how it looks in our sample app, and then she will do a live demo.
So now we're looking at the video analysis view model class. And especially, we want to look at the setup player method, where in this method, we are constructing everything Kristina just mentioned. So we start by we have the URIs for all of the videos, and each video will be represented as one item. So to start with, we pass in this local URI to media-item.builder. So we have the builder for the item. Then the AI magic happens. In here, we apply the start and end timestamps to the clipping configuration that we set on the media-item.builder. This step on its own just trims down the video for you to the segment that was suggested by AI. We build the media builder, and we pass it to the edited media item, setting the duration. If you want to add any video effects, any audio processors to your item, this is exactly where you would do so. So now that we have our list of edited media items, we want to set them to the composition. To do so, we pass these edited media items to the edited media item sequence that with audio and video from helper method. This will align all of our items sequentially in time to play one after the other. If you want to add any background audio, for this, it's going to now play the videos and any audio that the videos have. But if you want to add background audio, voiceover, whatever you need, or even if you want to do another video that's playing at the same time, you can do so that in here, where you add another edited media item sequence and pass in whatever you want to play to it. So now that we have our composition ready, we want to play that to the user. To do so, we define a composition player.builder passing in the context, and we build that. And simply enough, we set the composition to it and call prepare. So now that we have our player, we pass it along to the UI state, which will trigger our player composable to start playback for the user. As a pro tip, if you want to export this result and not only show it to the user, you want also to export it to a file, you can use Transformer API by passing in this same composition, so it will give you the same result that you were previewing. So now that we have our results in, we can take a look at our demo. All right. So I want us first to start by looking at the different videos that we want to play. And for example, here we have the first video. So of course, we're doing a tour in the London office. And we started with the first video showing around in the office. And then Kristina is saying hi at the front door with the Google logo. So this exact moment is what we want to view. So I would like us to skip this part, ideally. So AI should figure that out. So this is one of the videos. Another one is this one, for example, where we are walking in the quiet area. And to be honest, my favorite moment in here when we go out, because we have the landscape starting to show in here from the terrace. So we are going to pass these videos to AI now. So we select all of our videos. And then we click Edit with Gemini. So this is going to take a bit of time because of two things. First, we need to upload all of the videos to Google Storage, which might take some time, as you all know. And second thing, AI needs to analyze all of those videos, which could also take time. So perhaps we could jump to the backup video that we have. Here we can tell AI more things. So for example, I'm telling it here to create a fun highlight of the Google Office visit and make sure to show us the best perks there. Click Edit with Gemini and wait for the magic to happen. See, much quicker. I hope we can do this in real life. All right. See, now we skip the trees part. And we have our video in. And of course, for each one of them, we display the reasoning where AI tells us why it chose the segment exactly. We see now that it skipped to the moment that we're showing the nice pixel art and a view from the left showing not only the pixel art, but also the gem, and then skipping through to showing us the part where there is a landscape out there, showing us a bit more details from the landscape. And then I think this was like 15 seconds long video, and they trimmed it down to like 3, 4. And then, cheers. Yeah? Thank you. Now, should we jump back to the slides for a quick resources and end things up?
Yes. So that was all. Can you imagine? Yeah, so in about 25 minutes, we showed you how to build this app, and I hope you will check this out and try to build this on your own. One thing to know, there is a README there, so please follow to set up your Firebase project, to select the right model, which is Vertex AI, and also to make sure in Google Cloud to give permissions to AI to have access to the storage, just FYI. But it's all documented. So the resources, a reminder, this is where you can get the code. If you didn't have the chance, please go ahead. And this would be in AI Video Clipper folder. There are other samples, so please check those out as well. And obviously, because we are from Media3, I cannot not mention Media3 APIs in our library, open source. We are very active on GitHub, so if you have any questions or if you have issues or bugs to report, please don't hesitate to file an issue and a bug, and we will be on it, either me or Shahd or anyone on the team. Thank you so much.